Okay, stats, let's do 7.2, applications of the normal distribution. So when we talked about z-scores, to calculate them, it's x minus mu over standard deviation. And for the normal curve, standard deviation is 1, generally, the mean mu is 0. It takes any distribution and it puts it there. That's what the z-score does. Now, in your packet or in your formula sheet chart on Canvas, if you scroll all the way to the bottom, I think you can see it. There's this big chart of numbers which looks like this, only way bigger, the standard normal distribution, and you really are going to need to get used to using that moving forward. It tells you how much falls to the left or the right of certain, well, it always tells you the left, but you can use it to find the right, of certain z-scores. So you need to get used to using it and how to do so. Okay, so the IQ scores can be modeled by the normal distribution with mu 100 and standard deviation 15. An individual whose IQ score is 1.3 of 120 is 1.33 standard deviations above the mean. So what does that mean? It means that if you were to draw the picture, every standard deviation on each side, here's one standard deviation, 1.1 1/3 is right here. So the area to the left would be all of this highlighted area. Now, how much of, remember the area under the normal curve is 1, how much of the 1 is to the left? So basically, how many people have that IQ or lower? So if you go to the table, this is a cutout of it, I'm looking for a z-score of 1.33. So on the left, it has the whole number in the first digit. Across the top, it has the second digit after the decimal. So here's the 1.3, and here's the 0.03. Together they make 1.33. And you see that they cross at 0.9082. That means 0.9082 is to the left of 120. That means he's smarter than about 91% of people, his IQ is. I know IQ doesn't necessarily translate to intelligence, but on the IQ score, he's above that many people. So we're going to start by just practicing using this table. Now, the first part, number 2, says use the complement rule to find the area to the right of z equals 1.33. So what the complement rule is that if you take a number, the area to the left plus the area to the right equals 1, which also means that if you're only trying to find one of these, you subtract the other one to the other side. So the area to the left we knew was 0.9082 plus the area to the right is 1, so I need to subtract 0.9082 to get the other side. This is an important skill, so the area to the right should equal 0.0918. Why is this an important skill? Because that chart only tells you the area to the left, which means if it asks you for the area to the right, what you need to do is take the opposite, or 1 minus what you see, in order to find the area to the right. Okay, so number 3, let's practice. Find the area under the standard normal curve to the left of z equals negative 0.38. So we find the negative 0.3, find the one ending in 8. We see that the area to the left is 0.3520. Find the area under the normal curve to the right of z equals 1.25. So now I want you to either Google, you can either Google the z-score table, or you can go to Canvas and find the page which has this chart. The area to the right of z equals 1.25. Well, we know the area to the left of 1.25 is what we find in the chart, and that is 0.8944. We have to take the opposite of that, 1 minus 0.8944, which is 0.1056. Now, another thing we can do is find the area between. One thing to know, it says between negative 1.02 and 2.94. So here's negative 1.02. Here's 2.94. To find this area in the middle, I know my z-score tells me to the left. If I do to the left of 2.94, it gets all of this, including the middle, but also the left side. If I take the area to the left of negative 1.02, it gives me just the left side. So if I take the area to the left of 2.94 and then subtract off the area to the left of negative 1.02, that only leaves me with the area in the middle. So I need to find the z-score, or the area under the z-score of 2.94 and the one for negative 1.02. Now, if I look at my chart for 2.94, I notice that it's 0.9984. The area to the left of negative 1.02 using the chart is 0.1539. When I subtract those, I get 0.8445. So when you're trying to find the area between things, you'll find the area to the left of the higher one minus the area to the left of the smaller one. Summary, the procedure for finding the probability of a normal random variable. You can draw the normal curve and shade it if you want. Sometimes it helps people who are visual. You convert everything to z-score, and z-score is x minus mu over sigma, and then use the table. To find the area to the left, you just use the chart. Area to the right, you need to do 1 minus the area number in the chart, and then area between, you subtract z-scores. So let's do an actual problem here. Men have normally distributed heights with a mean of 69.5 inches and a standard deviation of 2.4. If a man is chosen at random, find the probability his height is below 6 feet. So my x is 6 feet. My mu, my average, is 69.5 inches. This is 72 inches, by the way. And my standard deviation is 2.4. So I need to do 72 minus 69.5 over 2.4. This is my z-score of 1.04. Now, what are the chances that they are less than 6 feet tall? Less than means to the left. So all I need to do is find the area to the left. So this is where I use the chart and look for where 1.04 is and find the number. So that would be 1.0 on the left side and 0.04 on the top. And find the number in the middle of them, in which case this number is 0.8508. So that means 85% of people are under 6 feet tall, roughly, for the normal distribution. I think that's pretty consistent. About 1 in 6 men are 6 feet or taller. Could be a little more here. I think Americans sometimes are taller than average. Texans certainly seem to be. Number 2, the length of human pregnancies are normally distributed with a mean of 268 days and a standard deviation of 50 days. What is the probability that a pregnancy lasts more than 240 days? So my x is 240. So 240 minus 268 over 15. It's negative 28 over 15, which has a z-score of negative 1.87. It wants above that. So here's negative 1.87. It wants to the right. So when I do my z-score of 1.87 and find the area, I get 0.0307. But remember, that's the area to the left. If I want the area to the right, I need to do 1 minus 0.0307, which is 0.9693. Now a quick note, there is an alternate way. Instead of doing 1 minus, if you take the number and do the opposite, instead of negative 1.87, you can do positive 1.87 and look to the area to the left because it's symmetric. The area to the left of 1.87 is the same as the area to the right of negative 1.87. So that's an alternate way to do it. If you look at the z-score table for positive 1.87, you'll notice it's the same thing. And we'll continue in the next video.